So, you're thinking about becoming a cloud engineer. That is a fantastic choice. Honestly, it's one of the most exciting and in-demand careers in tech right now. And in this explainer, we're going to lay out a clear, step-by-step roadmap to get you there, from the absolute fundamentals all the way to the advanced skills that'll make you a total pro. All right, let's dive into your roadmap.
First things first, let's just set the scene a little bit. Think about the old world of on-premises servers. If you wanted to deploy a new app, it could take weeks just to get the hardware ordered and set up. And if your website suddenly got popular, well, good luck scaling that manually. Now, flip that on its head and look at the cloud-native way. We're talking minutes to deploy, automatic scaling. It lets developers actually focus on building cool features instead of just waiting around. That's the power we're tapping into.
And you know what? That power translates directly into opportunity. The demand for cloud skills is just off the charts, making it one of the highest-paying fields in tech. We're talking average starting salaries well north of $100,000 in a lot of places. The money's great, for sure, but the career growth is even better.
So how do you actually get there? Well, we've broken the whole journey down into 6 key stages. We're going to start with building your foundation, then move to choosing your cloud, mastering the really powerful tools, automating your workflow, getting into the observability mindset, and wrapping up with the never-ending quest that is security.
Okay, first up, building your foundation. You know, a lot of people ask, can't I just jump right into learning AWS or another cloud platform? And while I guess you could, it's a huge mistake.
It really is the perfect analogy. Trying to learn cloud without the fundamentals is like building a house without a proper foundation. Sooner or later, things are going to break, and trust me, they will break, and you won't have the core knowledge to even begin to figure out why.
So what does this foundational toolkit actually look like? Well, it's these 4 things right here. You've got to be comfortable with the Linux command line. Most of the cloud runs on it. You absolutely have to understand networking, things like IP addresses, DNS, firewalls. Otherwise, you'll never figure out why your app is unreachable. A little bit of Python scripting is crucial for automation later on, and you definitely need to know the difference between SQL and NoSQL databases. These are non-negotiable.
All right, once you've got those IT fundamentals locked in, you're ready for stage 2, actually diving into the cloud itself. This is all about understanding the core concepts and then picking your platform to focus on.
Before you even log into a cloud console for the first time, you need to speak the language, right? What's the real difference between infrastructure as a service and platform as a service? What is this shared responsibility model everyone talks about? Like, what part is your problem and what part is the cloud provider's? And maybe most importantly, how do you keep costs from spiraling out of control? These concepts are the bedrock of everything you'll do.
Now, when you do log into a platform like AWS, it's going to feel overwhelming. I mean, there are literally hundreds of services. Here's my advice. Don't try to learn them all. Just start with the big 3. You've got compute, like EC2, which is just virtual machines. You have storage, like S3 for storing files. And you have networking, with VPC, to build your own private, isolated corner of the cloud. Just master these first.
Okay, on to stage 3, mastering the advanced tools. Look, clicking around in the console is fine when you're learning, but it's not how real work gets done. It just doesn't scale. To manage complex, real-world infrastructure, you have to level up from manual clicks to automated power.
And the solution to that is this incredible concept called infrastructure as code, or IAC. So instead of clicking around to create a server, then a database, then a network, you define all of it in a simple code file using a tool like Terraform. Then you run one command, and bam, Terraform builds the entire thing for you, perfectly, every single time. It's repeatable, it's reliable, and it's way less prone to human error. Next up, you've got to know Docker. This tool solves that age-old developer problem. Well, it works on my machine. We've all heard it, right? Docker lets you package an application and all its little dependencies into a neat box called a container. That container will then run the exact same way, whether it's on a developer's laptop or on a massive production server in the cloud. Problem solved.
But what happens when you have hundreds or even thousands of these containers? How do you manage all that? Well, you need an orchestrator, and that's where Kubernetes comes in. Think of it like an automated operations manager for all your containers. It handles deploying them, scaling them up if you get a rush of traffic, and even restarting them if they crash, all without you lifting a finger. It's the engine that powers modern cloud applications.
And that leads us perfectly into stage 4, automating the entire workflow. So you've got your infrastructure defined as code, your apps are neatly packed in containers, But how do you actually get a new piece of code from a developer's computer into production safely and quickly? The answer is you build a CI/CD pipeline.
A CI/CD pipeline, that's continuous integration and continuous deployment, is basically the automated bridge from development to production. So a developer pushes their code, that automatically kicks off a process that builds the code, runs a bunch of tests, creates a brand new Docker image, pushes that image to a central registry, and then finally deploys it to your Kubernetes cluster. The whole thing is hands-off. It just works.
So, why is this such a big deal? Why does it matter so much? Well, take a look at this. One team reported that before they built a CI/CD pipeline, their average deployment time from code complete to live in production was a staggering 27 days. Can you imagine the bottlenecks, the manual work?
And now, look at the after picture. With automation, that exact same process went from 27 days down to just 3.5 hours. This isn't just about going faster. It's about being more reliable, more consistent, and freeing up your engineers to solve real problems. The impact is just enormous.
Okay, stage 5, adopting the observability mindset. Once your application is up and running in the cloud, your job isn't done, not even close. You have to know what's happening inside that system. It's about moving from just reacting when things break to proactively understanding the health of your system at all times.
Let's use an analogy to make this really clear. Think of monitoring as the alarm system in a building. It just tells you when something is wrong, like CPU is high. Logging, on the other hand, is like the security cameras, recording everything that happens, line by line. And observability is the whole system working together, the alarms, the cameras, and the ability to trace a user's path that lets you figure out not just that something is wrong, but exactly why.
And that brings us to our final and honestly, our most critical stage, security. This is so important. Security cannot be the last step, something you just check off a list. It has to be woven into every single thing you do, right from the very beginning of any project.
At the absolute minimum, this means you have to master these core principles. First, truly understand what you are responsible for securing. Second, use identity and access management, or IAM, to enforce the principle of least privilege. That means people and systems only get the exact permissions they need and nothing more. You have to lock down your network and encrypt all your data, both when it's just sitting there and when it's moving around. And this is why security is such a relentless job. As a defender, as a cloud engineer, you have to be perfect. You have to patch every vulnerability, secure every entry point, configure everything correctly. An attacker, on the other hand, they only need to find one tiny mistake, one misconfiguration, one loophole. It's a tough game, and you have to be constantly vigilant. So there you have it. We've laid out the entire journey, from those foundational IT skills all the way to advanced cloud security. Look, the path is definitely challenging, but it's also incredibly rewarding. This roadmap gives you the structure you need to get there. So the only question left to ask is, what are you going to build first?